Welcome to my video series introducing R utilizing the Tidyverse set of packages. This is a video companion to my online notes for a course that I teach at Northern Arizona University. This course is intended for two purposes. The first, introduction section of the notes, is intended for individuals that have little to no experience programming, and I try to keep the R content sufficient for a student taking an introductory statistics course, but I avoid getting too deep into the details. The deeper details section introduces a data wrangling workflow and provides a much more comprehensive overview of each step that I introduce. This section is helpful for individuals who either have quite a bit of programming experience or aspirations to use R daily in their workflow. R is an open source programming language that has tons of additional libraries that are designed for statistical and machine learning. Now, separate from the R engine that runs the code, there's an integrated development environment, sometimes called an IDE, that we use to write and debug the R code. The best IDE for R is a program called RStudio. The people that wrote and support RStudio also provide many open source packages that are really great for doing data science in R. Both R and RStudio run on many different computing platforms, whether it's Windows, Linux, or the Mac operating system. To download R onto your computer, what you're going to do is you're going to go to a website that is www.rproject.org. Go to the download R link and then pick some mirror that is close to us. So we'll go down to the United States and pick something that's relatively close. Let's go to Iowa. And from here, you can pick whatever operating system you want to use, whether it's Windows, Linux, or the Mac desktop operating system. Unfortunately, there is no iOS or Android choices here. Next, you're going to want to go to RStudio.com in order to download RStudio. In this case, you'll go to the Download tab and then select the version that you want. In this case, we're going to want the RStudio desktop. Click on Download, and then you can choose what operating system you want to use, whether it's Windows, Mac OS X, or some flavor of Linux. Download those and get those installed. After you've installed R and RStudio, the first thing that you'll do is you'll open up RStudio and you'll see an image that looks sort of like this. Now, what I recommend that you do is you go up to File, New File, and scroll down to an Rmarkdown file. We're going to open up a new file. In this case, we're going to give it a title, and let's call this Example, and the author is me. Now, eventually we're going to create some sort of output file that you would give to your advisor or turn in for homework, and it could be an HTML or a PDF or a Word file. By default, I think I like defaulting to a Word file, but I also like PDFs as well. But that requires another piece of software, MikTeX on Windows and MacTeX on OS X. But let's start with Word here. So I'm going to open this up, and by default, when we start a new Rmarkdown document, it's going to be filled in with some examples here. And currently up here it says that it's untitled, so I'm going to save this to begin with, and we'll see what happens. And it's going to ask me where to save this, and I'm going to save this just to my desktop as testing.rmd, and I will save this. Alright, so what's going on is that within this document, you can have essentially two types of things. You can have stuff that is R code, and anything that is in this little backtick, 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 close backticks, anything in this gray area, these are going to be R commands. And anything on the white background, this is commentary. And anything inside these gray areas are going to be where we put R code. So for example, in this case, I've got a command that calls us summary information on a data set called cars. And you can also put plots as well. Now, notice that I've got some commentary, I've got some code, R code, but I don't have the output of that code. What's going to happen is I'm going to go up to this knit button right here, and I'm going to click this. And what's going to happen is that we're going to open up a completely fresh version of R, run all of the code that is in these gray boxes, and when it runs the code, it'll also get all of the output that that code generates. And then what it'll do is it'll put together a Word document that has your commentary, your R code, and then the output of that R code all put together in one document. The joy of this is that there's no copying and pasting of, here's my output, copy it into my Word document, here's some more code, copy that, here's the output, copy that, because unfortunately, copying and pasting never works well, and I always will make a mistake somewhere, somehow, and I'll end up turning in an article or submitting an article that has a discrepancy between the R code that I say that I wrote and the output that I actually get. And this is a big problem. And so this R Markdown sort of thing where you knit the document and have it run the R code and then it creates the document on the fly, that prevents having a mismatch between the output that you show and the R code that you use to generate it. Now notice in my Word document, I've got some commentary, and that commentary corresponds to everything inside your R Markdown in white. Now, my R code, this summary cars, you can see that's where this thing came from. That's my R code. But the output of that command showed up right here. So I never put that code there. That just got included just by running this knit command. So as a result, we've got an R Markdown document where I have commentary and then R code. And this is what goes in this editing pane. Most of my work actually is involved in this editing pane. Now down here, this is the console. Now I could type information down here. So I could ask it questions like what's 2 plus 3 and hit return, and it'll tell me information. But when I go and save my document and then come back a couple of days later, anything that I just typed into this console is effectively gone. So as a result, I always type up in this editing window, and this R Markdown document is where I store my commands, because frankly, nothing of interest can be done just in one sitting, and I need to save this file and then return to it a day later or a week later or a month later. So everything should happen up in this editing window. Now this environment tab is actually fairly interesting. I've loaded a data set called trees that's actually built into R, and you'll find a lot of examples use this data set. Now, you can look over in this environment and see that this trees data set has been loaded, and if I click on this little blue button, you'll see that this trees data set actually has 3 different columns. One of the reasons why I like having this environment tab open is that I can see that I capitalized volume, height, and girth. And the data set that I'm working with is this thing called trees. And this really helps me with my spelling issues and worrying about capitalizations, because unfortunately R is case sensitive. And so if I try to deal with a lowercase girth, then I would mess that up and R would complain that it doesn't know what it's talking about. So I like having this environment tab open. Now this final tab down here has a bunch of different things that you could do with it. Inside this files tab, this shows in my current working directory what all files are there. You also have this plots tab, and eventually when we start making graphs, I can make my plots show up here as well. And then finally, there's also this help tab in which I can look for help for a bunch of different functions. So if I were to look for summary, there's some information there. So this little pane down here is often referred to as the files, plots, and help pane. So RStudio basically has 4 different panes, but most of my time is spent in the editor and looking at what the output is in the console. most common mathematical things that you might need to do in R are relatively easy to do. We'll just open up a new R chunk, and you can put whatever mathematical thing you want here. You can do simple addition, say 3 plus 4, and run that, and you can see that 5 plus 4 is equal to 9 down here. You could do a bunch of other things as well. You could, if you wanted to do some sort of trigonometric thing, you could calculate, for example, the sine of some value. So you could calculate the sine of 1, which is, I guess this is the value for sine of 1. Sine of 0, if you wanted to calculate that. If you wanted to calculate sine of pi, pi is actually a built-in number in R, and so it knows that pi is 3.14159. And this number down here, this is a number times 10 to the minus 16. So in computers, when you're dealing with real numbers, 0 is sometimes an interesting number, and so this is actually as close to 0 as the machine tolerance. And so be aware that sometimes 0 is not exactly listed as 0. Other options you could do, for example, log. Log is this, and notice that when I typed log, this sort of tab completion link came up, and you can see that you can do log base 10, log base 2, log b. So this sort of gives you some other, this is for binary. So there's a bunch of different options, and you can sort of scroll through what are available. So when you're dealing with sort of doing sort of calculator style calculations, you could do it inside a R chunk, inside your R Markdown, but for just doing sort of quick calculator style things, I oftentimes will just go down into this console. This arguably is the only time that I type things into the console, is when I just want to do a quick sort of calculator thing and I'm too lazy to open up a actual calculator, but I always have RStudio open, so I use it as a calculator. Big shock. Being able to store the results of previous calculations is really important for making your code readable. And many statistical formulas are a lot easier to read and code correctly if we're going to use standard variable names. So we want to be able to do some sort of assignment here. Now within R, there's actually two ways of doing variable assignment. There is the arrow sign, which is this less than dash. And this arrow, I oftentimes read this when I'm reading code as gets. And this equals sign, notice this is a single equal sign, and both of these do the assignment operation. And what'll happen is it'll take this number, in this case my age, 43, and it'll assign it to this variable Derek. So I'll go ahead and run this chunk. And we see over in my environment tab, we see this Derek and this value of 43. And likewise, we'll do the same thing and we will run Aubrey, my wife, and her age is 39. And so both of these two statements have done assignment, saving a numeric value as now a variable, Aubrey or Derek. Now we can go ahead and do a little bit of calculations using these. And for example, we can take my age, divide by 2, divide by 7, which is sort of the standard creepiness. Oh look, it didn't recognize Eric. I had to actually highlight the whole thing. So now I'm going to go ahead and run this. And this is calculating the sort of standard creepy age for whether or not you date someone. Yeah, whatever. But the end result is I did a calculation based off of this new variable that I've already defined. And I could put two variables together and run those calculations and find out if things are set up correctly. Now in this case, this if-else command, go check out chapter 6 for what exactly this does, but we're going to run this chunk of code and calculate this new variable, this variable called creepy, and notice that this thing is labeled as a false. So here we've got some numeric values, a logical true or false thing, and then another numeric value. So these things, these variable names, they can take on numbers or true, false, or categorical things. They can take on a whole bunch of different things. But the way that I create those is using these assignment operators, which is this either arrow or equal sign. Now, it doesn't matter which you use, the equal sign or the arrow, but I would recommend picking one and sticking with it. Most functions and algebraic operations within R can be formed on a vector of objects, not just a single scalar. Now, this is super convenient because we often have tons of observations in our data sets, and it's really nice to be able to take a vector of things and a vector of things and multiply them together or add them together or do some sort of operation on all of the elements in that vector. So first off, what we need to do is we need to have a nice, easy way of creating a vector. So the way we're going to do this is using this function that is, well, you can call it the C function, but what it actually stands for is combine. And one way to check this out is to go down here and look at the C function. And what it does is it combines vectors or objects into, or it combines objects into a vector or a list. Now, in this case, the reason why it's such a short function name is because we do this all the time. I'm constantly making vectors. So in this case, I'm going to go ahead and I'm going to run this first line of code here, and I'm going to create a vector x. And over here in this environment, you can see this variable x, and you can see that it's a number. So it's a set of numbers, and there are 4 of them here, 1 through 4. And so this is object 1, 2, 3, and 4. And for those of you who come from a programming language like C, you'll notice that the first element in my vector actually is labeled 1, not 0. I think it makes sense. Anyway, so we can go ahead and make a vector using this C function. I'm going to make a second one, this y here, and you'll notice both of these are y's. Now, all of my algebraic sort of manipulations that I could do before, I could do on these vectors. So now I'm just going to add x and y together just to show you that this can in fact be done. And we see that 4 plus 5 is in fact 9. Now, oftentimes I need to be, this C function is a really nice way of creating an arbitrary vector by hand, but sometimes I'd like to be able to make a sequence of numbers that follow a certain pattern, and I don't want to list them out by hand. And so the way that we're going to do this is we're going to use this sequence command. And this sequence command, basically you need to give it a starting point. So this is going to be starting at 3 and an ending point 15, and then the step size. So the step size by 2. So this will give me 3, 5, 7, 9, 11, 13, and 15. So we can go ahead and look at this foo. Now, when I go ahead and create this thing, you could do a couple of different things. And you could start it at 1. And when I do tab completion, you can see the 3 different things that you can pass it. You can pass it starting from, going to, step size by. And those correspond to the 3 things that I gave up here. Now, by default, you kind of need all 3 of these things. But oftentimes, I want a step size of 1. And I want to do this so very often that there's actually a built-in thing to R that's sort of a shortcut to the sequence command, where I just use this colon operator. And you can use just about anything that you want. And in this case, I'm going to start with 8, and I'm going to go to 23. And my step size by default using this colon operator is step size by 1. And so this gives me a nice, easy way of making a nice long vector where I have a step size of 1, and it's really easy and really short to write. I do this very, very, very often. And so this sort of short, nice, easy way of making a vector of step size 1, the colon operator is a really nice trick. One of the best reasons to use R is the amazing collection of thousands and thousands of freely available packages, and the ease of making your own packages and sharing your own work. In fact, statistical methodology research papers typically will include an R package that makes whatever methodology they're working on widely available for people in their field. So to install a package from the Comprehensive R Archive Network, what we're going to do is we're going to go over to the Tools button, or the Tools menu up here, and go and click on Tools, and we're just going to go down to Install Packages. And what you're going to do is you're just going to type in the package name that you want. In this case, I want something called Dev Tools, and notice there's also tab completion there. And make sure that you've got this little check mark down here that says Install Dependencies, and that'll make sure to install all the packages that DevTools also depends on. So this is a sort of one-stop shopping and easy installation. It's almost one click. So we're going to go ahead and in this case, this is something that I've already uploaded, say no to that. But it's going to install a couple of different packages, and it just goes out to the internet and it installs it on my computer, and we're all done. So now, one of the things that we can do is we can use whatever package we just used. Now in particular, I'm going to go ahead and use this DevTools packages, and I'm going to use a function within the DevTools package. So what we have here is this kind of package name, function name, naming scheme right here. And the reason why we have this is that there are thousands and thousands and thousands of packages, and some of them have functions that are the exact same named functions. And so I need to be able to specify the package name and the function name together. So in this case, we're going to go ahead and download a package that I wrote called Sizer. And so we're going to go ahead and do that, and it looks like this is up to date because it hasn't changed since then. And so we now have the most up-to-date version of this package. So this is fabulous. Now we have a package that lives on my computer, and with just a single line of code to access it. So one of the things that we might want to be able to do is to sort of not always use this sort of package name : function name, because sometimes the package names are really long and it gets really old. So one of the things that we could do is we could add all of the functions in a package to my namespace so that I don't have to do things like package vegan. So I could go vegan : and then some function name. If I do this library, what it does is now in all of the packages that just get loaded, I can use whatever function I want from that package, and I don't have to type the package name. Typically, in most of my R Markdown files, the very first R chunk will be a couple of library commands that will load the libraries that I most commonly use. For this course, the one that you're going to see most often is this sort of meta package called the tidyverse. And we'll talk about that more in a while, but this first chunk of code typically just loads packages so that I've got more files and functions to work with. Now, the very last thing that we might want to do is I want to load some data sets from a package that I've just downloaded and installed from the internet. And probably the best way to do that is using this data command, where you can specify what package you want to load the data from. So what I'm going to do is I'm going to load the alpha data set from a package that I downloaded from the internet called the Faraway package. And all I did was I went up to Tools, Install Package, I installed the Faraway package, and it goes out to the internet, it goes and grabs it, and now I can easily install this alpha data set. And right now it's a promise because it sort of delays as long as possible, but as soon as I go and start looking at it, we have the full data set and we can see a whole bunch of stuff. So our very next thing. Another confusion that I find that students have is that the way that RStudio works for me can be a little bit different than it works for you just when you install RStudio. And the reason is because there's a lot of customization that you can do to RStudio to make it work and behave the way that you want. So I've introduced the idea of having an editor and a console, but that's not the only way you could have it. For example, we could have it where instead of where I've got my code and I execute my code and it pops out down in this bottom pane and this bottom pane just kind of scrolls, I could change it so that my document sort of looks a lot closer to what the output document is going to look like. So let's go up to RStudio, I'm going to go to Preferences, and I'm going to go down to Rmarkdown. And one of the ones that I find students get most confused at is this option right here, this Show Output Inline for all Rmarkdown documents. I'm going to go ahead and select that, I'm going to apply that, click OK. And now what's going to happen is when I run this line, it's going to put the output right underneath my my R code, so that I end up with my commentary, my code, my output, and then some more commentary. So as a result, now my Rmarkdown file looks a lot more similar to what the final document is going to look like. It's your preference whether you have the console or you have the output inline. The next thing that we want to do is start looking at data frames and how to manipulate them, but we'll start to do that in our very next video. Thanks for watching. Have a great day.